Hi there! Today I want to show you how to build your own DIY tubular frame based on one of my designs. If you're not sure what I'm talking about, please check back on this channel soon because I'll be releasing more videos about these designs and the reason behind them. As usual, the best way to explain anything is through demonstration. So today we will assemble together a Neo 6-inch frame, which is the latest design that I've released. I'm currently building several of them in different sizes. This one here is what I'm going to call this thick version, because it's very beefy and super robust. But the version that we will assemble together now is going to be the slim version, which is lighter and more focused on efficiency. In general, building a DIY tubular frame can be divided into 5 steps. You can use the chapter marks below to navigate to the section that you need, but what you need to do is 1. Ordering the carbon rods and printing the necessary parts on your 3D printer. 2. Preparing the 3D printed parts for assembly. 3. Cutting the rods. 4. Assembling everything. And 5. Gluing the frame together. First step, ordering the rods. Currently, the best worldwide source for carbon rods is, well, AliExpress. I know with the tariffs and everything it can be a bit difficult, but I hope that's going to pass soon. I have 2 sellers that I've purchased from many times in the past and that I can recommend, one for glossy rods and one for matte ones. I've added links to both in the description below, please check there. If you source them elsewhere, make sure to get the woven material rods, which have a fabric-like structure on the surface. I recommend avoiding pultruded rods, as they're not really meant to be touched with your hands, and small fibers can end up in your skin and they get sticky, icky. That's just annoying. So it's always better to get ones that are woven, sometimes called 3K, whatever. You'll see. Usually they are a bit more expensive than the pultruded ones, but still very reasonable. For printing the parts, we need to distinguish between the core clamps that hold the tubes together and then the various mounts for your electronics. The core frame parts, plus the mount for the flight controller, which is a bit special because that also needs to be as stiff as possible, they should be printed with a very stiff material. From my experience, the best filament to use is PACF, followed by PLA+. PACF is a bit difficult to print because you need a hardened nozzle and you need an enclosed chamber, but if you can do that, it actually is a bit simpler to print than normal PA with the added carbon fiber, but yeah, that's just the way it is. Or PLA+, which is also fine, just don't leave the frame lying out in the sun for long in summer. PETG also works, but due to its glassiness, like it breaks very easy, and then with hard, I don't know, it's not ideal. But the topic of which filament to use is also a regular topic on our Discord server about tubular frames. If you ever are interested in joining the discussion, then feel free to join the server. The link is also down there in the description. Now for the mounts, I suggest using TPU. It will reduce possible vibrations in the camera feed, and since it's flexible, it will protect your gear in case of a crash because it will bend a bit, and that's fine in that case. Any TPU basically is fine, really. I personally use one that is a bit harder and less flexible, but that's totally up to you. Now in my later designs regarding printability, I focused on making all parts as easy to print as possible, and usually the core frame parts can and should actually be printed without supports. This will ensure that you have the least amount of effort by removing supports and everything before continuing with your build, and you won't need it because it will not improve the shape of the holes anyway. And for the mounts, you will need support in most cases, and I recommend setting your slicer to 3 supports and on build plate only. This will make it easier for you to remove the support after. Regarding the core frame parts, you can decide if you want them to print them with a maximum robustness. That means print them 100% solid, no infill. Like if you want to do a bando basher, then that's what you want to go for. And if you want to have a lighter frame for long range and stuff, then 15 to 20% infill is also fine. And anything in between as well, that's just your personal preference, how far you want to go for robustness versus how light it's going to be. Even with 15% infill, it's still going to be very stiff, the whole frame overall, so you're not going to have any vibration issues that way. So that's really just regarding robustness. Alright, now you've printed the parts and you're ready for the next step, which is preparing them like the parts for assembly. One really annoying thing about the otherwise great carbon rods that you can get is that they are usually not true to their stated diameter. They can even differ in diameter between one end of the rod and the other, and I've seen them off by more than 0.2 millimeters, so a rod that should be 6 millimeters can easily be 6.2 or 5.8 millimeter. And that might not sound like much, but it matters a lot when you want to fit them into clamps. And I've designed the parts to work with your average carbon rod, if there is one, but it's very likely that you'll need to do some post-processing at all. If you have a caliper, you can check the actual diameter yourself, or just test if it will fit the printed parts like that, or that it will need post-processing. If you need post-processing now, well, you need to widen the holes. And normally you would just take a drill and make them fit the size that you need. You could even get a drill with a larger diameter, like 8.1 or 8.2, and that would work better. However, before you go out and buy one, I may have a better suggestion. Because the problem with the drill is that the tip is conical, which is great for drilling into material, but not exactly great for widening a cylindrical shape. And I've been looking for better tools, and I found something called a reamer. And a reamer is an awesome tool because the tip is almost completely straight, not completely, but almost. And this way you can remove much more material up to the very end of the hole than with a normal drill. And this will make it easier for the tube to fit in that hole then. The great thing about these reamers is also that you can get them for the same price as a normal drill, and you can also get them on like AliExpress and stuff for a few bucks. And I highly recommend getting one with an 0.2 millimeter bigger diameter than what you want to go for, so 4.2, 6.2, 8.2, because in that way you're going to be fine in 99% of all rods, I guess. I'm sure there's going to be some that still need a bit more effort, but usually that's going to be it then. And this will greatly reduce the effort that you will need to take in order to widen these holes. Now, whether you have a drill or a reamer, you just attach it to your drill and you widen the holes accordingly. There is no trick to it. Just try to be as straight as possible, because otherwise things might be twisted in the end. But it's not crazy. Normally, you can make small corrections without any issue in the next step, and this is what we're gonna look into. Okay, now the next part is going to be cutting the tubes, and I will only cover this part briefly today. I might make a separate video about it, we'll see, but one big disclaimer. Always wear a mask when cutting the tubes, because any carbon fiber dust that you inhale is going to stay with you for the rest of your life and cause all kinds of problems. So stay safe, ideally cut the rods outside, and in any way wear a mask. A good mask like FFP2. Now after COVID, I guess everybody has some. That's perfect, use them. Regarding tools, you can use a handsaw to cut them. If you're doing it indoors, ideally cut them in water or underwater, because this way any carbon bits that might be flying around will be bound to the water. You can also use a Dremel, which is quicker but creates very fine dust, so even more justifies wearing a mask. Or you can build the rod cutter that I've designed, which is a very cheap rotary tool that it uses, which you can get for, yes, you guessed it, AliExpress for 20 bucks or so. You just screw it on, and then you have a great tool for cutting the rods, and it doesn't get any simpler than that. But I understand it's some effort to do, so for the first frame you can just use a handsaw as well, and you're going to be fine. I also do recommend that after you cut the rods that you clean them under the sink, because there is a lot of fine carbon dust on them and inside of them, and with the running water it just flushes out, and that is a great way to clean them easily, and I recommend doing so because otherwise the dust, well, has to go somewhere. Alright, now you've cut the rods and you have the parts printed and prepared, so now you can put the frame together and glue it, and this is what we're now going to be doing together on the bench. So first of all, we need your rods, and then also your printed parts. Now the question is, how do we get all that together? Well, in order to do that, usually with every design I release something like this, where you can see what the rod lengths are and stuff like that. And this helps us to at least position the rods in the right order. So we have the longest one down here, then we have the two next ones here, then the outer front ones, then we have, like, these are almost the same lengths, but we see that the ones in the front here are a little bit shorter. So these are the ones who go in the front, these are the ones who go in the back, and these are the ones who go on the outside. Now that's for the rods. Now for the clamps, this one is pretty simple. This is the one in the middle. So let's already start putting it through. So that's first, then I don't know, there is no special order for this, but this is just the way that I usually do it. You now take the one for the front, you add these sides here. So, and now I take the ones who go in the back. Just slide them on. Now for this one here, I roughly check, and this is why it's helpful to do this on top of a mat, such like this one. I place this in the middle, so I see on the left and the right side it's about the same distance. And then I check where the middle is, and then I roughly align these like this. This is actually I guess this is the part that is the most difficult when aligning it, to get these ones right and in the middle. But we can realign this later down the road, so that's fine. So let's just stick those together like that. Then we have the motor mounts. For this frame here, we have the back motor mounts where the motor is mounted in between the rods, and the front clamps where the motors are over the smaller inner tubes. So let's put those here. That one goes here. No, actually, that one goes here. This one goes here, and that one goes to the front. And then we have those here, and here we have one which is a bit longer that goes to the back. So let's add that. Here are the ones who are a bit longer. This one goes here, and that one goes here, and that one goes here, and that one goes here. So what I usually do next is that I put on the motor mounts here on the outside, and then I just from the outside in put in the stiffeners. And now I can align the middle clamp with them. Now the other one. Like that. Also goes in. When you feel that it goes a bit more difficult, that's fine for now, because we still have a lot of room to make sure it's correct, but you can see that, of course, it is because it's not glued yet, it moves around quite a lot, but that's okay. It won't do that later on. Now the same to the front. Front motor mounts go on. Then stiffeners go through. Did I? No, I think I swapped those. Yeah, this looks about right. So these go on like that, and in here, all the way in. Same for the one on the left side. Motor 4. Let's get it in real good. Oh, I forgot the stiffener, or the, I don't know, whatever you want to call it. They're all stiffeners, but the side rod mount. So let's add this one here, and now we can move it in. Perfect. Now for the side ones, these you can still move around. So what I usually do is I move them a bit further apart. I put it in on one side, and then I just move them together until they make contact, and then I push it in, and I'm gonna do the same on that side as well. Here the contact, and now let's push them in. Perfect. All right, now that we know where everything is gonna go, this can go away. Now I'm gonna check again the alignment, if these clamps here are aligned, if it's rectangular or not, and it is not. So let's just push things around a little bit. This looks good. Okay, I mean, now this is just a dry fit. This is not going to be glued like right now, the way that it is now. We need to take it apart again, but putting it together once first in a dry state is very important to get yourself familiar with it, to see if everything fits well, if there are any, I don't know, any gaps, any misprints. I don't know, if you printed all the parts that you need, if you got all the rods and stuff like that. That's very important. But basically this is what we now need to reach the state after the glue has been applied. And this is what we're going to do next. I'm now going to prepare the epoxide. I'm going to get it and then I'll be back. So before we continue by taking this apart, let's first set up the glue. Now, you can use super glue to glue everything together. However, super glue snaps off rather easily. It's very solid and in place, but on impact, it could happen that your rods and the clamps are getting separated. That's not a problem. Actually, you can fix that relatively easy on the field. However, I personally like to use something which is a bit more rigid, and that is epoxide. Epoxide is a two-component glue, which consists of a binder and a hardener, and you need to mix those up yourself. And yeah, normally it is like the one that I'm using. It has a 50-50 ratio, but there are different ones. I really suggest using one that has a longer curing time. Like mine has about 8 hours of curing time, so you have a lot of time after putting it together to correct things if something went wrong. This is a problem when it's just a 5-minute epoxide, which takes 5 minutes to cure. Then you are under quite a bit of stress. Of course, the advantage of using super glue is also that you can just push in the glue now into the parts, so you don't need to disassemble it again. However, like from my experience, epoxide makes a much better connection. So we're going to use epoxide now for most of the clamps, not all of them, because some, like here, that have holes where you push the rod through, it's impossible to get epoxide in there well. So here I will later down the road also use super glue. But the most important parts where epoxide is needed is the motor mounts on the outside and this part in here, because when you have an impact, the force goes in here and there will be a lot of force going onto this part here. So these and these definitely epoxide, and these here as well. The rest you can use super glue. However, wherever you can use epoxide, epoxide is better. So let's now mix up the glue. Yeah, that's about the same amount. And now I mix those up. Mix them up real good. And now they are active. Now if I would do nothing, it would cure and get hard. So let's move that away. And now, one thing I forgot is to get gloves. So I'm gonna get gloves now. Now gloves are important because things are about to get messy. So let's move this aside. And now let's basically disassemble it just the way that we did assemble it before. Move out the stiffeners. Like that. All right, now I usually start from top to bottom, or from outside to the inside. So I will remove this and remove that. And now I'm gonna put glue into the openings of the clamps. Let me show you. So I use this this brush. I don't know, I got 100 of them for literally nothing. Not the, I mean, even after they cured, you can reuse them. It's just not going to be fluffy anymore, but for getting this inside, it's still going to work. But yeah, I don't know. You can also use a Q-tip or something like that. So I put these in, and that's already a good first step. Now I'm doing the same with the back mounts here. So let's try not getting epoxide everywhere, because that is a real pain in the ass to clean up. But into here real good. All right. Now let's put these in here. All right. First step, we already put a little bit of epoxide on here, but that's fine. Let's just clean it off while it's still nice and liquid. All right. Now I'm also going to add epoxide into these rod openings of the center clamp. Like this. And like that. And on the other side as well. Flip it over. And here. All right. So now that's, oh, by the way, regarding the orientation, what is top and what is bottom, when I design the parts, I do usually make one side round, like with a fillet, like this, and then when you tell your slicer to automatically rotate the items the best way possible, it will automatically make this the lower side. And here you have the RX antenna mount, so that's also a hint, but yeah, that usually helps for the slicer to do his work best. So let's now push this in here. Perfect, we're doing good so far. Now let's push in those here and those here. And now come the motor mounts, and what I like to do here is that I put some here in the beginning of the hole. Yeah, like that. I'm gonna do the same here as well. And trust me, this is so much more relaxed if you don't have to hurry because the glue is gonna cure. I'm just a little bit under stress because I don't want to have this video be too boring for you guys. So I don't want to have you wait forever for stuff to be happening, but let's see. So let's take a little more, put it in here. We might need to add a little bit more epoxide because it's already running low, but let's see. Okay, now I push in the first rod here, and actually better remove this one here because any spillage, which will happen because I added a bit much, but that's fine. I prefer to add a little bit too much, better than too few. Now you can try getting some of it out if you need it because you're low on epoxide, but that's not really necessary. Because after it cures, it's gonna get, there is no color, so now it's milky, but after it dried, it's gonna get transparent, it's gonna get clear, so no problem at all. do the same down here. Pro tip, something that I always remember when I'm already doing it, put some sort of paper or whatever protection on your work desk, because then you won't make a mess, which is what I'm doing here right now. Before the recording, I switched around this cutting board, this cutting mat, because that part up here is already full of epoxide from previous endeavors. Yeah, but I didn't want you guys to see that, so let's also remove the excess from here. All right, so now I don't put epoxide in here like in the stiffener motor mounts, because I'm gonna push this all the way through and that's gonna get way too messy. So I'll leave that. I'm gonna push it through first. Like that. Now to realign the center rod like that. Okay. Now, I push this in, but I don't push it in all the way, because for the last bit, I'm gonna add at least some epoxide on the outside of the rod. Not too much, because most of it is gonna end up on the rod anyway, but just so that it has a nice little coating. And then I push it in all the way. You know what? I accidentally switched the front and the back stiffener rod. So, okay. Well, I mean, as you see, stuff like that happens all the time, and that's also why I like to use epoxide that doesn't cure too quickly, because then I have time to fix things like I'm doing now. So push the stiffener over here. Now that feels better. But that's a good thing, we have plenty of time, because before this glue cures, we are going to be long gone. All right, now let's try this again in the front. Yeah, I was already a little bit confused because somehow it didn't really add up the length, but now it does. So let's see. Okay, now again I add some epoxide here on the outside of the rod, and maybe I'll just put some in here as well. Why not? Maybe even a little more. Like that. And now I'm gonna be pushing it in fully. Like that. Let's wait with these on the outside until we've also added this side here. So this time let's check, okay, the longer one goes in the back and the shorter one goes to the front. Now let's put the stiffener in place. Actually, yeah, we can just take the clamp. All right. I hope you can see well enough. I'm trying my best here. I hope it's okay. So let's put on some epoxide here. And again, I like that idea in here. Should talk to you guys more often. I have great ideas just talking to myself. So now let's push it in. Let's see that it's almost fully in, just a little bit looking out. That's perfect. You can see already that it starts getting a bit more liquid. That's with epoxide as it sets. It does that. And also it gets more milky gradually. So now the back stiffener thingy. And for number 4 we also do the same thing. Yeah, it's plenty of epoxide. I won't need any additional. And oh, we don't have the inside motor mounts, but let's add a little bit more here. It will also sink down when curing, and that's going to help make a better connection. All right, so let's push this in fully. Perfect. Now what's remaining is these stiffeners here, and what I'm going to do is I'll just pull this out, twist them upwards, and now in goes the epoxide. One. Let's get it all in there. One more. Now with epoxide, I personally always take a bit too much, because like when it's more solid, like at the beginning, you feel like, yeah, I can add more, it's gonna stack up. But once it cures, like I said, it starts to kind of like liquefy, and then you have a big mess on your hands. All right, let's push this in a way that it's almost straight, but we're gonna do all the alignment in a second. The final alignment. Now we're just gonna make sure that everything is on there. Push it in. All right, so that's a good thing, but what I'm going to get now is a piece of paper that we can put underneath, which I should have done from the beginning. So actually 2 pieces of paper. All right, actually, okay, let's wait with the paper because I need the mat underneath to see if I'm aligned well. So what I do is, like, here is the center line that I'm using, and I'm checking first left and right, do they have the same distance? And they do. That is great. So then I check that the front and the back, that they are, like, the middle here is on that line and the back here is on that line, like that. Then I check if the left and the right rod here are the same. This one can move a little bit to the outside. I mean, it's not a 100% thing anyway, but I want to make sure I do the best that I can, so that it all is looking good. Now, one final thing, make sure to check that everything is flat. Like when you push down on each side, that it's not moving up or down. Then you need to tilt the frame, but it's not doing that. So now, finally comes the paper. And now I'll just let it sit like that until it's cured. I usually check in again after, I don't know, an hour or so, when it's still pretty, when I can change things, to double check if everything is okay, because also sometimes, I don't know, if it sits for a bit and things the epoxide does its thing, then yeah, I just want to double check that nothing has moved in a way that I don't want it to. What I'm doing now is just remove some of the excess epoxide, because as usual I made a bit of a mess. That's just because I'm nervous. All right. Okay, so now I'm done. Now let's have it sit for a while. So the epoxide has cured now, which is great. And now we just have to put super glue on the places where we did not reach with the epoxide. So I will just use any old ass super glue that I have lying around. There's no special requirement here. And now we have especially those middle parts here where the glue needs to go into, as well as the stiffeners. And I'll add some here on these back rods, because this is where we've been pushing it in from the outside, so I'm not sure if it really got everywhere. And also here on these parts. Now the way I designed these is that there is a little bit of space inside between this side and this side, so some epoxide has reached this side here as well, but I'll just add some super glue to be safe. So I'll just place it here and push it in. I'm sure there are a lot better ways to do this, and if you have an idea, I'd be very glad to hear, but otherwise I'll just add a drop of it on each side first, and then I'll turn it around and do it on the other side. But let's put it on all places here. That side as well. And now here, the back. Make sure that it has contact with the rod and the clamp. I'll also add some back here. And here, well, I see epoxide here, not here, so let's just be safe. The good thing in the front here is just epoxide, and that's all super solid, so no need here, and I can hold it here nicely. That's usually a problem when you try to glue too many places. You'll end up with super glue on your fingers, which is annoying. Except you're demonstrating for nature, which we had in Germany not a while ago. People were gluing themselves to the street in order to demonstrate for global warming and such, which is a good intention, although if that particular way is the best, I'm not so sure about. So yeah, let's add some here as well, you know, why not? It's just super glue. Super glue, super cool. Okay, did I miss anything? Let's check. No, looks good to me. Maybe here. The super glue is gonna seep into the little crevices, which is great. So it's gonna do our job for us, basically. Oh no, there's enough in here. All right. Now let's let this sit. What I usually do, let me just grab it, is to place it onto just something that I have lying around, ideally something that does not touch any of the glue points, like that. And now I'll let it cure until also the super glue is set, and that's it. Now when the super glue is cured, your frame is complete and you can mount all your favorite stuff on there. Regarding what builds you can do after, like with which parts to use, I will make a separate video, but for today, this is it. I really hope that this video helps you and makes you a bit more confident with building your own tubular frame, and that you'll enjoy doing so. If you need any support at all, please feel free to join the Tubular Discord community. There are many others out there with experience on there who will be happy to support you just as much as I would. The link is down there in the description. So see you on there or out there or anywhere. See you again next time. Take care. Bye. I think I need to order another gallon of super glue. Wow.